Hi, I'm Bob Lazar. During late 1988 and early 89, I worked on the propulsion systems of extraterrestrial vehicles for the United States government. The hardware and technology I was exposed to should be placed in the proper hands of the scientific community, and it is the right of every person on Earth to know that there is physical evidence which proves that there is life elsewhere and that at least one form of that life has been here. For those of you whose information about me is limited to this video, I'll give you a brief background. I'm a physicist. I have degrees in physics and electronics technology. I've worked in a number of scientific programs, some of which require top secret and above top secret security clearances, of which the most easily verifiable is my early 1980s job here at the Los Alamos Mason Physics Facility in Los Alamos, New Mexico. Between December of '88 and April of '89, I worked as a senior staff physicist in what has to be the most secret project in history. My place of work was a facility at an area known as S4 on the Nellis Air Force Range in central Nevada. Area S4 is located approximately 15 miles south of the infamous Area 51 installation at Groom Lake, where the U-2 and SR-71 spy planes were developed. For the duration of my employment at S4, I was paid by the United States Navy. For the purpose of this video, I'm going to segregate the information contained here into two separate parts. The first part will deal with information with which I've had hands-on experience and personal instruction. In other words, not only did I read briefings and not only was I taught the theories of these technologies, but they were demonstrated for me and I know they are true and accurate. Some of the points covered in this first section will be how vast distances of space are traveled by virtue of an intense gravitational field, how this gravitational field is generated, what the power source is and how it functions, and general information about disks and the project at S4. The second part of this will deal with subjects on which I've read supporting information, yet for the most part I had no other way to corroborate the information or ascertain its accuracy. When we get to part two, it'll be obvious why proof of some of this information could not be conclusive. Some of the points covered in this second section will be information about the beings that brought us this technology, and how these beings have historically interacted with man. I've been prudent in selecting what to expose here, and I think that some of this information should not be made available to the general public. This information is being conveyed to you as it was to me, with the exception that in most cases I've simplified things for those of you with non-scientific and non-technological backgrounds. So let's begin. At the beginning of this first section, I'm going to give you 3 short science lessons, and once you've learned them, you'll not only know more about interstellar travel than almost anyone else in the world, but you'll know the actual method another civilization is used to travel from another star system to the planet Earth. Now, during the course of this, I'm going to have to relate information that I've learned at S4 to information that we're already aware of. And when I say we, I mean the general mainstream scientific community. So as not to waste too much time explaining established scientific facts and theories, when I say we know this or we know that, please feel free to consult any qualified scientist, professor, or science teacher to have them explain my statements to you. One of the most predominantly asked questions is, how is it possible to cross vast expanses of space without exceeding the speed of light? Or how can you travel in reasonable time and economy between points that are light years apart? Now keep in mind that the speed of light is 186,000 miles a second, which translates into roughly 669 million miles an hour. And a light year is a distance traveled in 1 year at the speed of light. Proxima Centauri, which is the star system nearest ours, would take 4 years to reach traveling at the speed of light. So up until now, when we've examined the requirements to travel these distances, we've always had to consider the problems of traveling at a speed near the speed of light. This poses problems with propulsion, navigation, fuel capacities, and even when you consider the effects of acceleration on space-time, which include time dilation, mass increase, length contraction, and a whole host of other things, it quickly becomes evident that this type of travel would require a level of technology that man has not yet achieved. The truth of the matter is that traveling these distances does require a level of technology that man has not yet achieved. but it has nothing to do with flying in a linear mode near the speed of light. We know that the shortest distance between 2 points is a straight line, so in our universe we've always assumed that the fastest way from point A to B was to travel in a straight line at the speed of light. Well, the fact is that when you're dealing with space-time and you enjoy the capability of generating an intense gravitational field, the fastest way from point A to B is to distort or warp or bend the space-time between point A and B, bringing point A and B closer together. The more intense the gravitational field, the greater the distortion of space-time and the shorter the distance between points A and B. Most of us think of space-time as the void or as nothing. And remember, it wasn't that long ago that man considered the air in our atmosphere to be nothing. Yet with time we've become aware of the elements and properties of the air in our atmosphere. Well, indeed, space-time is an entity, and one of its properties is that it can be distorted or bent by a gravitational field. We know that gravity bends or distorts space-time and light by virtue of the fact that we're able to see stars which we know should be blocked from our view by the sun. Referring to the graphic here, the solid line denotes the position of a star that's located behind the sun, and the dotted line shows its position as viewed from Earth. This is made possible because the sun's gravitational field distorts the space-time and light around the sun, allowing us to view stars which would be hidden from view. We know that gravity distorts time by virtue of the fact that if we take two identical atomic clocks and keep one at sea level and take the other one up to a high altitude, when we bring them both back together, they reflect different times. The difference in this passage of time is caused by the fact that a gravitational field weakens the further you get from the source. So the atomic clock which was taken to the high altitude was exposed to a less powerful gravitational field than the clock which we kept at sea level. The effect of a gravitational field on space-time is something that we've been able to observe, but not to experiment with. This is due to our inability to generate a gravitational field. And up until this point in time, great mass such as a star, planet, or moon was the only source of a discernible gravitational field that we're aware of. So just as the gravitational field around great mass such as a planet distorts space and time, any gravitational field, whether naturally occurring or generated, distorts space and time in a similar manner. Now, the great benefit of generating an intense gravitational field is not only can you turn it on, but you can turn it off. If we refer back to our original illustration of space-time distortion, we can see that when we generate an intense gravitational field, we can distort the space-time and in turn the distance between the point where we are and the point where we want to be. We can then position ourselves at the point where we want to be and then stop generating the gravitational field, allowing space-time to return to its natural form. In this manner, we can travel great distances with little linear movement. And this is how space-time distortion translates into reduced distance. Now back to our original question, how is it possible to cross the vast expanses of space required for interstellar travel without exceeding the speed of light? This is accomplished by generating an intense gravitational field, distorting space-time and allowing you to cross many light years of space in little or no time and without traveling in a linear mode near the speed of light. The next question is, how do you generate a gravitational field? Up until this point in time, I've used the term generate to describe the capability of producing a gravitational field, but since I'm not aware of any way of creating a gravitational field from nothing, a more accurate term might be to access and amplify a gravitational field. And this is what I mean when I use the term generate. To understand how gravity is generated or accessed and amplified, you must first know what gravity is. There are two main theories. The wave theory, which states that gravity is a wave, and the currently accepted theory of gravitons, which are alleged subatomic particles that perform as gravity, which is total nonsense. Well, gravity is a wave, and there are two specific different types of gravity, gravity A and gravity B. Gravity A works on a small or micro scale, while gravity B works on a large or macro scale. We are familiar with gravity B. It is the big gravity wave that holds the Earth as well as the rest of the planets in orbit around the Sun and holds the Moon as well as man-made satellites in orbit around the Earth. We are not familiar with gravity A. It is the small gravity wave which is the major contributory force that holds together the mass that makes up all protons and neutrons. Gravity A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel. To keep them straight, just remember that gravity A works on an atomic scale, and gravity B is the big gravity wave that works on a stellar or planetary level. However, don't mistake the size of these waves for their strength, because gravity A is a much stronger force than gravity B. You can momentarily break the gravity B field of the Earth simply by jumping in the air. So this is not an intense gravitational field. Locating gravity A is no problem because it is found in the nucleus of every atom of all matter here on Earth, and all matter anywhere else in our universe. However, accessing gravity A with the naturally occurring elements found on Earth is a big problem. Actually, I'm not aware of any way of accessing the gravity A wave using any Earth elements, whether naturally occurring or synthesized, and here's why. We've already learned that gravity A is the major force that holds together the mass that makes up protons and neutrons. This means the gravity A wave we are trying to access is virtually inaccessible, as it is located within matter, or at least within the matter that we have here on Earth. However, the Earth is not representative of all matter within our universe. The residual matter which remains after the creation of a solar system is totally dependent on the contributing factors which were present during the creation of the solar system. This is true whether you believe that the origin of the universe was an evolutionary event or that a supreme being caused this event to happen. The two main factors which determine what residual matter remains after the creation of a solar system are the amount of electromagnetic energy and the amount of mass present during the solar system's creation. Our solar system has one star, which is our Sun, but the majority of solar systems in our Milky Way galaxy are binary and multiple star systems. In fact, many single star systems have stars that are so large that our Sun would appear to be a dwarf by comparison. Keeping all this in mind, it should be obvious that a large single star system, binary star system, or multiple star system would have had more of the prerequisite mass and electromagnetic energy present during their creations. This makes it possible for these systems to possess elements which are not native to the Earth. Scientists have long theorized that there are potential combinations of protons and neutrons which should provide stable elements with atomic numbers higher than any which appear in our periodic chart, though none of these heavy elements occur naturally on Earth. 88 of the first 92 elements on the periodic chart occur naturally on Earth. Some heavier elements do occur in trace amounts, but for the most part we synthesize these heavier elements in laboratories. Generally speaking, the stability of these synthesized heavy elements decreases as their atomic number increases, but experiments at the lab for heavy ion research in Germany have shown that this may only be true up to a certain point, as the half-life for element 109 is longer than that of element 108. The point is that our observations and theories are accurate. The fact is that heavier stable elements with higher atomic numbers which have more protons, neutrons, and electrons than any Earth elements do exist. However, up until this point in history, there has been no physical evidence to prove this. But now that proof is here. The most important attribute of these heavier stable elements is that the gravity A wave is so abundant that it actually extends past the perimeter of the atom. These heavier stable elements literally have their own gravity A field around them, in addition to the gravity B field that is native to all elements. No naturally occurring atoms on Earth have enough protons and neutrons for the cumulative gravity A wave to extend past the perimeter of the atom so you can access it. Even though the distance that the gravity A wave extends is infinitesimal, it is accessible, and it has amplitude, wavelength, and frequency just like any other wave in the electromagnetic spectrum. Once you can access the gravity A wave, you can amplify it just like we amplify any other electromagnetic wave. To demonstrate how a wave is amplified, we can use this oscilloscope, and as you can see, it graphically depicts the tone you hear as a wave. As we amplify the tone, you can see that the size or the amplitude of the wave increases, giving us a more powerful version of the same identical wave, and thus the tone sounds louder. In like manner, the gravity A wave is amplified and then focused on the desired destination to cause the space-time distortion required for space travel. This amplified gravity A wave is so powerful that the only naturally occurring source of gravity that could cause space-time to distort this much would be a black hole. This brings us back to our original question: how do you generate a gravitational field? you must have access to an element which is heavy enough for the gravity A wave to extend past the perimeter of the atom. Then you can access and amplify it for space-time distortion. To complete our 3 science lessons, the last question is, what is the power source for this type of travel? Well, for those of you with limited knowledge about power sources, I'm sure you can probably imagine the enormous amount of power required to cause a space-time distortion for this type of travel. After all, we're amplifying a wave that barely extends past the perimeter of an atom until it's large enough to distort vast amounts of space-time. For those of you with extensive knowledge about power sources, I'm sure it's probably even more puzzling as to how it's possible to have a compact, lightweight, onboard power source that can provide this much power. For everyone to understand that, I need to further explain a couple of things we briefly touched upon in the last question. If you remember, I said that for the most part, we synthesize or create heavier elements in accelerators, and their stability decreases as their atomic number increases. So what does this all mean? Well, we synthesize these heavier, unstable elements by using more stable elements as targets in a particle accelerator. We then bombard the target element with various atomic and subatomic particles. At this point, transmutation occurs, making the target element a different, heavier element. This element now has a higher atomic number, as the atomic number simply indicates the number of protons in the nucleus of the atom. So this is what I mean when I say their atomic number increases. What does their stability decreases mean? The length of time which an element exists before it decays determines its stability. Atoms of some elements decay faster than atoms of other elements, so the faster an element decays, the more unstable that element is considered to be. When an atom decays, it releases or radiates subatomic particles and energy, which is the radiation that a Geiger counter detects. As you can see, this Geiger counter is detecting the radiation from this uranium, which literally means that the Geiger counter is sensing the subatomic particles which are being released or radiated as the uranium decays. Those elements in which nuclear radiation can be consistently detected are radioactive elements. These heavy elements, which we synthesize in particle accelerators, are of the radioactive variety, and they decay very rapidly. Since we're only able to make a few atoms of these elements, and because they decay so rapidly, we're not able to observe much about them. This is what I mean when I say their stability decreases. However, there are elements with higher atomic numbers which are stable, even though they don't occur naturally on Earth, and we can synthesize them in particle accelerators. These are the elements in the 114, 115 range which don't appear on a periodic chart. Beyond element 115, the elements become unstable again, and in fact, element 116 decays in fractions of a second. This finally brings us to the power source. The power source is a reactor which uses this element 115 as its fuel. In this reactor, element 115 is used as a target and is bombarded with protons in a small particle accelerator. When a proton plugs into the nucleus of an atom of 115, it increases its atomic number and becomes an atom of element 116, which, remember, decays instantly. What element 116 releases as it decays, or what it radiates, is antimatter. What is antimatter? Antimatter is the exact counterpart of matter, which has a charge and a spin that is in the opposite of all matter. When combined with any matter in our universe, antimatter reacts and completely converts to energy. And remember, the rapid conversion of matter to energy is what we generally call an explosion. To demonstrate the explosive power of antimatter, let's pick a random area where an atomic bomb might explode. Oh, let's say Iraq. And for demonstration purposes, let's say an atomic bomb would explode, for instance, in, Baghdad. Well, if one of our older atomic bombs exploded in Baghdad, the area of total devastation, which is indicated by the red dot on the map, would be approximately 2 miles. This would be caused by a fission reaction in which less than 1% of the nuclear material is converted to energy. Most of you are familiar with the bombs that were dropped on Japan in World War II. This is the same bomb that was dropped on Nagasaki August 9, 1945. About this same time, Dr. Edward Teller, who's known as the father of the hydrogen bomb, figured out that a nuclear fusion bomb was possible. Fusion would release even more energy and cause an even bigger explosion from the same amount of nuclear material. Much to Dr. Teller's dismay, the Japanese surrendered, we never dropped the hydrogen bomb, and Dr. Teller's been in a bad mood ever since. But if a hydrogen bomb containing the same amount of nuclear material as the Nagasaki bomb were to explode in Baghdad, the area of total devastation would be approximately 20 miles. This would be caused by a nuclear fusion reaction, which again, less than 1% of the nuclear material actually converts to energy or explodes. The other 99% of the nuclear material on this type of bomb is dispersed, but is not involved in the actual nuclear fusion reaction. Now, if a bomb was made with the same amount of nuclear material as the Nagasaki bomb, and that material was antimatter, when that bomb exploded in Baghdad, the area of total devastation would include parts of Africa, Europe, and Asia, with the exact area of total devastation being very difficult to calculate. This would be caused by a total annihilation reaction, which is the complete conversion of matter to energy. 100% of the nuclear material on this bomb would explode or convert to energy. We currently have no practical way to harness antimatter into a bomb, and generally speaking, we can only isolate antimatter in a particle accelerator and store it for a short time. This demonstrates the enormous amount of power released when you totally convert matter to energy, which is what happens when antimatter and matter are combined. So back to our power source. Inside the reactor, element 115 is bombarded with a proton, which plugs into the nucleus of the 115 atom and becomes element 116, which immediately decays and releases or radiates small amounts of antimatter. The antimatter is released in a vacuum into a tuned tube, which keeps it from reacting with the matter that surrounds it. It is then directed towards a gaseous matter target at the end of the tube. The matter and antimatter collide and annihilate, totally converting to energy. The heat from this reaction is converted into electrical energy in a near 100% efficient thermoelectric generator. This is a device that converts heat directly into electrical energy. Many of our satellites and space probes use thermoelectric generators, but their efficiency is very, very low. All of these actions and reactions inside of the reactor are orchestrated perfectly like a tiny little ballet. And in this manner, the reactor provides an enormous amount of power. So back to our original question. What is the power source that provides the power required for this type of travel? The power source is a reactor which uses element 115 as a fuel and uses a total annihilation reaction to provide the heat which it converts to energy, making it a compact, lightweight, efficient onboard power source. I've got a couple of quick comments about element 115 for those of you who are interested. By virtue of the way it's used in the reactor, it depletes very slowly, and only 223 grams of 115, which is just under half a pound, can be utilized for a period of 20 to 30 years. Element 115's melting point is 1740 degrees Celsius. I need to state here that even though I had hands-on experience with element 115, I didn't melt any of it down, and I didn't use any of it for 20 to 30 years to see if it depleted. So we've learned how space-time is distorted by a gravitational field, we've learned how that gravitational field is generated, and we've also learned where you get the power to accomplish all of this. Now it's time to link all we've learned in our science lessons to the vehicle that utilizes all of this technology. And a few years ago, I never thought I'd hear myself say this, but that vehicle is a disk, which is generally referred to as a flying saucer. I had at least partial views of the 9 different disks out at Area S4, but the one I'm going to describe to you now is the one in which I not only saw 2 of the 3 interior levels, but I also saw it fully functional in flight. And no, unfortunately, I didn't get to go for a ride in it. This particular disc appeared to be in excellent condition, and because of its sleek appearance, I nicknamed it the Sport Model. The Sport Model is about 16 feet tall and 40 feet in diameter. The exterior skin of the disc is metal, which is the color of unpolished stainless steel. The Sport Model sits on its belly when it's not energized. As you can see, the hatch is located on the upper half of the disc with just the bottom portion of the door wrapping around the center lip of the disc. The interior level of the disc is divided into 3 levels. The lower level is where the 3 gravity amplifiers and amplifier guides are located. These are the things used to amplify and focus the gravity A wave that we learned about in our science lessons. The reactor is located directly above the 3 gravity amplifiers on the center level and is in fact centered between them. The reactor is similar to this half-scale model. The element 115 is machined into triangles like this and is then inserted into the reactor. This piece of element 115 is the source of the gravity A wave as well as the target that is bombarded with protons to release the antimatter, both of which we learned about in our science lessons. The center level of this disk also houses the control consoles and seats, both of which were too small and too low to the floor to be functional for adult human beings. The walls of the center level are all divided into archways. At one point in time, when the disk was energized, one of the archways became transparent and you could see the area outside of it just as if the archway was a window. After the panel had been transparent for a while, a form of writing, which was unlike any alphabetic, scientific, or mathematical symbols I've ever seen, began to appear on the transparent archway. And I was never informed as to how all of this was achieved, not that any of that would have required alien technology. I was never given access to the upper level of the disk, so I can't enlighten you as to what the porthole-like areas are, other than I can assure you that they're not portholes. Now, before I go any further about the disk, I'm going to show you where and under what circumstances I saw it tested. My job in this program was to be part of a back engineering team. Back engineering is the act of taking a finished product and tearing it apart to find out what makes it tick. The goal in this program was to see if the technology of the disk could be duplicated with Earth materials. When I went to work, I was flown from McCarran Airport in Las Vegas to Area 51, which is a highly secure government base on the Nevada test site. Area 51 is located about 125 miles north of Las Vegas near the Groom Mountains and the Groom Dry Lake bed. From Area 51, I was bused to an even more highly secure facility located about 15 miles south of Area 51 called S4. S4 is situated at the base of the Papoose Mountains by the Papoose Dry Lake bed. The airspace around S4 is restricted, and if any unwelcome aircraft strays into the outer sector, they radio the pilot and instruct him or her to leave. If that pilot continues and strays into the middle sector, jets will be scrambled to escort the intruding aircraft out. If for any reason whatsoever that aircraft penetrates into the inside sector before jets can be airborne, ground-to-air missiles will neutralize the intruder. The moral of this story is don't try and fly into S4. The S4 installation is built into the mountain and the 9 hangar doors are angled at about 60 degrees. These doors are covered with a sand-textured coating to blend in with the side of the mountain and the desert floor. As you can see in this representation, my ID badge had a white background with one light blue and one dark blue diagonal stripe in the upper left-hand corner. At the bottom of the badge, there were letters and numbers designating various areas, including S4. On my badge, there was a star punch through S4. The back of the ID badge was dark blue with a vertical mag stripe running down one side. The hangar that housed the sport model was like a typical airplane hangar with the exception of the angled doors that I mentioned before. The hangar was equipped with typical tools and extensive electronic equipment. It also had a machine with an X-ray emblem on it and an overhead crane rated at 20,000 pounds. Equipment in this hangar was marked with a black number 41 with a white circle around it. It was outside of this hangar that I saw the sport model tested. Now, when the disk travels near another source of gravity, such as a planet or moon, it doesn't use the same mode of travel that we learned about in our science lessons. When a disk is near another source of gravity, like Earth, the gravity A wave, which propagates outward from the disk, is phase shifted into the gravity B wave, which propagates outward from the Earth, and this creates lift. The gravity amplifiers of the disk can be focused independently, and they are pulsed and do not stay on continuously. When all 3 of these amplifiers are being used for travel, they're in the delta configuration, and when only one is being used for travel, it's in the omicron configuration. As the intensity of the gravitational field around the disk increases, the distortion of space-time around the disk also increases. And if you could see the space-time distortion, this is how it would look. As you can see, as the output of the gravitational field from the amplifiers becomes more intense, the form of space-time around the disk not only bends upward, but at maximum distortion actually folds over into almost a heart shape around the top of the disk. Now remember, this space-time distortion is taking place 360 degrees around the disk. So if you were looking at the disk from the top, the space-time distortion would be in the shape of a donut. When the gravitational field around the disk is so intense that the space-time distortion around the disk achieves maximum distortion and is folded up into this heart-shaped form, the disk can't be seen from any vantage point, and for all practical purposes is invisible. All you could see would be the sky surrounding it. The program out at Area S4 consisted of 3 projects. Project Galileo, Project Sidekick, and Project Looking Glass. Project Galileo dealt with gravity propulsion and was the source of all the information you've learned in this first section. Project Sidekick dealt with a beam weapon that had a neutron source and was focused by a gravity lens. Project Looking Glass dealt with the physics of seeing back in time. Now, I was not personally involved with the hardware of Project Sidekick or Looking Glass, and those projects are beyond the scope of this video. So this brings us to the end of this first part, in which I'm presenting to you as fact.